Hello everyone, welcome to today's Data Engineering Masterclass. We are privileged to have Damilola Ojo join us for today's class. Just before I introduce our facilitator, let's get to know more about Data Science Nigeria. Our vision at Data Science Nigeria is to build 1 million African AI talent in 10 years. We tend to achieve this through our end-to-end artificial intelligence ecosystem. We are the number one artificial intelligence learning community and solution delivery network in Africa. In 2019, we received the prestigious Matai Impact Award at Deep Learning in Daba. We also run the biggest free artificial intelligence learning platform on the continent across different campuses and cities, with 26 unique platforms delivered through face-to-face, online, offline, and hands-on approaches. We have impacted hundreds of thousands of people in Africa. Our platforms target people of different segments, ranging from beginners to kids and teens to intermediate and experts to students to professionals, C-level executives, and government agencies. Here are some of the pictures from our AI Plus community activities. Our AI Plus community is currently in 18 universities and 23 cities in Nigeria. We run practical data analytics classes for professionals across different industries. And some of the companies that we have trained include Shell, ARM, Aximansad, to mention but a few. We drive industry level knowledge through our AI for Executive learning sessions. And here are some of the pictures from the session. Please visit this website, that is www.datasciencenigeria.org/new trainings, to discover more about our training programs. Now, if you have been considering learning data and analytics or starting a data science career, here is an opportunity for you. Don't miss our special May Professional online classes. The classes start tomorrow, May 16. And guess what? You can still register to attend today. Please call Sheun on +234 814 00 88800. I'll go over that again. +234 814 00 88800. You can join the business and data analytics stream, which goes for just 30,000 naira, that is less than $100. And you can as well also join the data visualization classes, which goes for just 20,000 naira.
Okay, so I chose data science because, it's the future.
The vision of DSN, I identify with it. It's something I can relate with. The vision of wanting to create a hub for data scientists in West Africa. It's something that is highly needed.
Okay, so far so good. It has been a wonderful one. I was able to learn the use of data to interpret data, to predict the future, definitely.
My big take home is probably sentiment analysis and then the use of big ML.
Today we did data visualization, dealt extensively with Power BI. There's a whole lot I can do with it. Things that we've been trying to analyze, I can now visualize it and it will make more sense to my audience.
Big ML majorly, it has been my own major takeaway, and the lectures were so broken down such that anybody can understand it.
What Sheun told me is lesser than what I even experienced there. The facilitators, they took us like children. It was like a dummy taking the course.
Tell everybody I come in contact with, especially young people in school right now, jobs as we know it will no longer exist. So you should get trained, in one of the technical skills. It could be data science, machine learning, artificial intelligence. That is the future.
So for me, DSN the vision is something that every forward-looking Nigerian should identify with.
And you can download our annual reports by visiting this link. Now, let's meet our speaker. Damilola Ojo is partner and head of data farm analytics enablement at DeltaPartners, based in Dubai, United Arab Emirates. He has over 14 years of experience working in the United States, Europe, Africa, Middle East, Asia, and Latin America. His rich work experience cuts across software engineering, ETL development, data architecture, data modeling, and data strategy. He has worked previously at SAS UK, MTN Nigeria, and CWG Nigeria. Ladies and gentlemen, please welcome Damilola Ojo to this session.
Hi everyone. How are you doing today? I know different people are watching from different parts of the world. I hope you are well and keeping safe. I know we're in trying times as we speak. However, I hope you and yours are all well and keeping safe. My name is Damilola Ojo, and I'll be running the Data Engineering 101 class for Data Science Nigeria. I'll be going through some selected material just to give a quick overview and try to cover as much as possible on the topic data engineering. I assume some of you are familiar with the topic already, and it's not new to you. Some of you might actually not have much of an idea of what data engineering is about. Hopefully, we can get a balance in the information I share today to give you at least a good understanding of what this at a first level. So let me tell you a bit about myself. So I was born and raised in Kano State in Nigeria, and I spent the formative part of my life in Kano. I speak Hausa, Yoruba, and English. My primary and secondary school education is in Kano State, and then I moved to university in Ibadan. So I attended the University of Ibadan and studied BSc Chemistry. So I guess the question is, how did I move from chemistry to into IT and into data analytics? That precisely shows that the space that I currently work in, or that most of us watching this video work in, data analytics, is quite open to everyone. And there's no barrier to entry. You just need to be ready to learn as much as you can and try your hands out on different things, and hopefully get a break to getting a job somewhere that can allow you to then grow. My first working experience was actually as an Oracle database administrator, and I worked for the federal government of Nigeria in 2002 as part of the electronic voters registration system. That was the first time they were actually setting up electronic voters registration in Nigeria, and they implemented Oracle database. And I, after leaving university to try to move into IT, I did an Oracle database administrator certification, and that was the opportunity to actually use the knowledge I had learned during the training. So it was a contract job, which lasted for a few months. And after that, I got my first permanent job working for Computer Warehouse Group. I guess most of you in Lagos or even in Nigeria, you should know Computer Warehouse Group is probably the largest, no longer local because it's also in West Africa. Software, not just software, they do other things beyond software as well. But I worked in the software arm there. It's really a reputable organization in Nigeria and has grown a lot of the IT professionals. A lot of my colleagues who used to work back then are working in different parts of the world now and working in top companies or running their own company. I worked as a software engineer implementing banking applications. There was a banking application called Finacle, and we implemented for most of the banks, the UBA, First Bank, the big banks in Nigeria. I was part of a lot of the projects back then. And after that, I moved to join MTN, and that was really my first exposure to data analytics. I joined the enterprise data warehouse team in MTN as an application developer, and we're in charge of managing the operational data warehouse, supporting different business areas, marketing, sales, customer relations, and so on and so forth. And I had my first exposure also to SAS in MTN. I was actually trained in South Africa in base SAS. And after working for a few years in MTN, I decided to relocate to the UK, initially for personal reasons, and then also to pursue new career opportunities. And I was lucky enough to get a job with SAS UK, which is one of, as you know, the top companies in the space of analytics. I worked for them for 4 to 5 years as well, and then actually left to start my own company, and I was contracting in the UK, which you don't have here in my profile, but I contracted for a year and a half for different banks, but mainly for Royal Bank of Scotland. And then finally, I was approached by my current company, DeltaPartners, and I moved to Dubai with my family to join DeltaPartners. DeltaPartners is a global strategy firm. It's a boutique firm focused in the telecoms, media, and technology space. And we basically do strategy consulting, although the practice I work in is the analytics practice. And one key differentiator for us is that we use a lot of the analytical knowledge we have to support the recommendations we provide to our clients. So this is how well, my career has evolved over the years. Sorry, my screen just went off now. Yeah, I think I'm back. So this is how my career has evolved over the years. But I guess the key message here is that I'm just like you. My starting point is not different from most of you watching this video. And with different opportunities that have come my way, self-development, mentorship from different people, getting exposure to things like Data Science Nigeria. Actually, back then, there was not much of this available. It was mainly people who had been through the process before me that shared their experiences and also helped me to see exactly what are the things that I wanted to do. And when the opportunities came, I tried to grab them as much as I can. And I'm here today. I think I can say that the journey has been good so far. There's still more to come ahead. And my encouragement for you will be that to stick to what you really want to do. Don't get discouraged. You may not have all the knowledge now, but as you continue to learn and get exposure through this great opportunity you have through Data Science Nigeria, hopefully you can get the knowledge and the opportunities and the connections to help you achieve your dreams. So enough about me. What do I plan to cover today? So I want to give a quick overview of the data engineer role, and I'm sure I've seen other courses already that have been delivered by different experts, and they've more or less covered things around data science and why is data scientist different from data engineer. I'll just give a quick overview here as well, and then I'll try to go into what I call the data to decision cycle. You'll see it. A lot of you may already be familiar with some of the concepts there, and there are some selected components of the data decision cycle that I want to cover, plus also talk about some of the domains and disciplines that as a data engineer, you should be familiar with. So, quick overview of the data engineer role. So as you can see on the left-hand side, we have the data engineer and the responsibilities. On the right-hand side, we have the data scientist. It's always good to compare, even though, to be honest, most data scientists also have a lot of data engineering skills. A lot of data engineers also eventually end up as data scientists. So don't think that there's a clear boundary or divide, It's just for you to understand sometimes where the focus is for each of these roles, then you can use this as a guideline. So the data engineers are responsible, of course, for the architectural side of any data ecosystem. So they help to develop, construct, and maintain the architecture. They ensure the architecture is built for purpose, so it will support the requirements of the business. They help to discover new data that can allow you to do different things with the data analysis and so on. They then develop the data set, the processes that help to generate the data sets. So move data from one place to the other to create data structures that can be used to drive decisions, to drive analytics use cases, and so on and so forth. And they employ a variety of languages and tools. Generally in this space, you would have been exposed to a lot of tools and languages already if you've been working within this space. And they then also look into improving the quality of the data, because ultimately the decisions that will be driven by some of the data that they generate are quite critical, so they need to ensure the quality. Whereas on the right-hand side, you see a list of things that the data scientist usually covers. I will not go too much into that because I just wanted to show you this. You can read it and see a bit the difference. So in terms of the data science workflow, there are a number of things, of course, starting from understanding precisely what problem you want to solve. And I think this is very, very critical. I've seen also some other courses that have been delivered talking about you need to start from understanding what problem you want to solve, what question are you asking, and so on. That would help you to really start on the right path. So business understanding is very important. And that's why you find a lot of people who have domain knowledge, who have been doctors or lawyers or worked in specific industries, can learn data science and actually then apply that knowledge to their industry because they already have a good understanding of the business. So this is very critical. Then followed by the data understanding, you need to really get into the data, get your hands dirty. Don't be scared of tearing the data apart, doing different exploration of the data. And then they import the data into the environment where they want to create different data structures or build models. They clean the data. Then you can do the more data science stuff, which is statistical modeling and machine learning. And finally, reporting your outputs by building visualizations or presentations. The data engineer, as you can see, the blue side of this image shows how much of in each of these different steps, what part the data engineer is more focused on. Is more on the data understanding, data importing, data cleaning, and ultimately reporting and visualization. They're also involved in that. But you can see that the business understanding is also key. So if you're aspiring to be a data engineer, don't think that only the data scientists need to understand the problem to be solved, but you as a data engineer also need to understand this, because as a starting point, you need to know what problem you're trying to solve, what data is available to solve that problem, and then understanding which data point or exactly how can you prepare the data to make it good and fit for purpose. So tools. Lots of tools in this space as well. Traditional tools like Oracle, SAP, Microsoft, new age tools, more recent tools, and open source tools like Hadoop, Spark, and so on and so forth. So what's important is you need to have desire to actually be able to use different tools to be able to program and code in different languages. I think for a data engineer, a fundamental starting point is for you to be able to program in SQL. I see a lot of new data engineers or data scientists who still don't know how to program in SQL. I always recommend that you still get your basics right, because SQL, in most production environments, in most industries, they still have one database or the other that still requires you to write SQL. Even in the open source tools, a lot of them have SQL compatibility. So very important as a starting point that you get at least some SQL knowledge, and then you can build on top of that. But as a data engineer, you need to be open to use different tool sets. So, and in terms of training and certifications available, there are lots of certifications and trainings online that you can check out for yourself. I've selected a few here, but this is not exhaustive by any means. But what is important is to you, as you're developing your career, it's good also to test your skill sets, to train, to retrain, and to validate your learning. Certifications are good ways to validate your learning, but also it's good on your CV because ultimately people will want to know how credible your skill sets are. By being certified by a reputable institution helps and goes a long way. Of course, this is not a substitute for true hands-on knowledge. However, if you've built the knowledge, it's good to also put the flag on it through a certification. All right. Then let's go into the main chapter for today's discussion. So like I mentioned, I'll be covering the data to decision cycle, looking at selected components of the data to decision cycle, and also then covering selected domains and discipline. So what is the data to decision cycle? Basically, as you can see here, the top image you have and the boxes you have there, from the left-hand side to right, as data moves to ultimately enable decisions, you need to go through a number of different steps. So you need to be able to collect the data, you need to be able to process the data and store the data, and ultimately you need to be able to analyze and visualize the data. I've simplified this. There are different versions of this available online that could have multiple steps, more than 3 steps, and so on and so forth. But what's important is it's still almost like the basic logic of input, process, and output. The data needs to be ingested, collected and ingested. Some processing needs to happen on it and some manipulation. And the data needs to be published or generated for as an output to be used for specific different purposes. So across the value chain today, I want to explore what is the objective of the different steps here. What are the objectives of the different steps here? What are the data components that you typically hear as a data scientist? Some of these are very basic, but we'll just go over them again. What are the key domains and disciplines that you should be familiar with as a data engineer? So objectives. For data collection, of course, the main thing is to get access to the data. You want to be able to get access to as much data as you can, because the more data you have, the more you can explore, the more you can find useful data points to drive analysis, to drive data science work, to drive different use cases. Then once you've done that, you want to then process the data. And the objective here is to make the data ready and available for use. You need to be able to structure the data in the right shape and form to ensure that the objective or the reason why you've collected the data is prepared and put in a structure that can enable that. So there are different reasons, right, which you can see on the right-hand side. It could be for visualization. You want to build a report or a dashboard. It could be because you want to build a machine learning model. It could be because you want to feed the data into another system for system integration purposes. The objective needs to drive what you do even in the processing of the data. But ultimately, what you do there, the aim is to make that data in the right shape and form so that it can help to enable the objective. And finally, for data analysis and visualization, you want to be able to deliver insights for decision making. You want to drive decision making. You want to drive an action. You want to drive some form of action. It might be innovative action. It might be execution of some initiative. It might be driving some system action, so on and so on and so forth. So always important to bear in mind, why are you doing these things, even as a data engineer, not just to get lost in the code or to get lost in the tool. You need to bear in mind there is an objective for every action you take across this data to decision cycle. So let's explore a bit the different components here, and I'll spend a bit more time. The way I've done this presentation, I'm using a lot of pictures because, again, I don't want you to be reading the text. As much as possible, I'll try to voice over. I'll try to annotate actually, I don't have my pen here. On the screen. And then you'd basically listen to what I'm saying and try to complement that with further research and also the sources of the information that I'll be sharing here. I have a link at the bottom of each slide, so you can also refer to that. So some of the components here that I've selected to talk about, of course, data collection, you're talking about different files generated from web applications, different systems. Nowadays, everything generates data, right? So it could be in the form of a file, it could be in a database that you can extract the data from. When we're talking about data processing and storage, I'm talking about typical things like the data warehouses, the data lakes, analytical sandboxes, and even something as traditional as an OLAP cube. These days is not really used as much, but it still exists as a data structure that helps you to make the data ready and available for use. Then ultimately in the data analysis and visualization, here standard reports and dashboards. But the focus today will be really mainly in the data processing and storage. This is where we have a lot of the concepts that you must have heard of. And just trying to give a good overview of what they are and share as much details based on my experience working in this domain. So if we look at the component that we talking about here, so this is actually the data warehouse. Let me flip back 1 second. So like I said, I'll be focusing a lot more on the data processing and storage. So let's look into the data warehouse. Here, data warehouse supports the traditional business intelligence architecture. So it sits right in the middle of this image. As you can see, the data that is being collected is a structured data, right? So the data is structured because it's in a tabular format, is in a format that is standard for databases, which is you have columns and rows. The data is extracted, is transformed, is structured, and then is loaded into an enterprise data warehouse. From the enterprise data warehouse, then you can also create more business-oriented data structures that are called data marts. These data marts, what they do is they consolidate the data in a way that they can enable specific type of reporting. So if you want to report on sales, if you want to report on different things around maybe marketing initiatives, you want to report on customer-related information, and so depending on what you want to report on or what type of decision you want to drive, the data mart consolidates the data in that way and gives you the specific metrics that you need to drive that decision. Then at the bottom, you see the OLAP cube. The difference here is the OLAP cube gives you a multidimensional view of the data. So typically when you're looking at a metric, you want to see it by different, what you call dimensions. So if you're looking at a metric like the number of products that were sold, right? You want to look at it by maybe the stores where they were sold. You look at it by the date at which they were sold. You want to look at it by which customers purchased them. So all these different views of the data is what you call a multidimensional view. And the OLAP cube stores the data in a way that allows you to be able to do that multidimensional viewing, but also allows you to do other things like a drill down from aggregated level. So when data is more aggregated, when you have summed up data or averages and things like that, you can actually drill down into the more detailed data. But the point here is that the data warehouse as a philosophy is basically linked to understanding data, transforming and loading the data. But a lot of time is spent making the data ready for use. And this time really impacts the time that is left for you to do the analysis. If you've been exposed to data warehouse environment, you'll realize that there's a lot of heavy lifting that is done on the data and a lot of preparation, which always impacts the time to market. And the challenge you have is being able to optimize that time, but also deal with more complex data structures, which you will see why there's been a shift. Not total shift, because you still have a lot of data warehouses in most industries, but there's been a shift towards newer technologies and new architectures, and you'll see, we'll cover that in a bit. So data discovery is a challenge here, and not all data is analyzed because you captured a lot of data, but you may not be able to structure everything, put it in the shape and form in time for it to be used for decision making. So you must have heard about big data, right? I'm sure this is not new to you. When we talk about big data and the era of big data, what exactly has happened? Basically, is because a lot of things have changed about the type of data we generate today. If in the past, the type of data we generated were mainly what you call transactional data. These were data that came from like sales records, so from like retail stores that were selling products. When they captured the sales information, these were sales records that were stored in a database. It was all structured. Not a lot of things were shared digitally then. But now we have a lot of things that are being digitized. You have a lot of images that have been shared on social media. You have a lot of videos that have been shared. You have a lot of things that are not structured in a tabular format that have been shared. You have a lot of texts that are free text that are shared online in chat messages and so on. So this has changed ultimately the structure of the data. So things around what you call veracity has changed because, again, what you have there, that 1 in 3 leaders don't trust their data. Data quality costs $600 billion per year because of course, the nature of the data has changed. The variety of data that you also collect, it's changed. You're collecting from different sources and different types of data. So you're collecting images, you're collecting videos, and so on and so forth. The speed at which data also comes, which is the velocity that you see, has changed. So data used to come a lot in what you call batches, which were maybe daily batches. So every day you could collect in the data warehousing environment anyway. You had what you call a daily load typically, or sometimes you had many batches that you could collect data from the systems that generate the data at that level of frequency. On a daily frequency, at the daily frequency, or within the day, you may collect it multiple times, maybe 4 or 5 times. However, now the volume at which the rate at which we generate data is so fast that when you look at the data we generate on social media, and when you look at in the smart city context, where you have what you call sensors, and these sensors are basically collecting information, environmental information, or collecting location information, or collecting movement, all types of information are generated. Or if you think about information generated in the utility space, so when you have the power generation companies, they record information from the meters in the house. That's like reading your energy consumption per second, right? So if the information is being generated and transferred and stored in a database, the speed at which they need to capture and store that information needs to be very, very fast, right? So the velocity of data is changing, and of course the volumes. Now we're generating data every day, every time. Every time you go online, you generate data. Every time you use your phone, you're generating data. So the volumes have grown. So the storage capacity that is required to hold this data is huge. And the traditional platforms or databases like the data warehouse are not able to cope for a number of reasons, which we'll explore a bit more. I guess some of the reasons for not coping is linked to the fact that they've been designed to work with specific type of data. The cost linked to this platforms is quite high. So storing more data means more cost. And they're not prepared to ingest the data rapidly because of the fact that you need to structure the data before you push them into the data warehouse. So the definition of what you analyze in data has changed. Traditional sources of data has been disrupted. So I used this a while ago actually to explain what it means, what impact it has in the time to extract value from your data. Because ultimately, you want to use your data to drive decisions, and you want to use that decision to drive opportunity to make money, to monetize your business, whatever assets you have, to improve your business, the sales, or to try to reduce your cost, whatever decision you need to make. The data needs to help drive that and to generate the value. If you spend a lot of time capturing the data, storing the data, managing the data, analyzing the data, it would, before you get to the point of generating value, you would have expended a lot of time. And the fact that data is now being generated based on the previous slide we saw, different structures, different volumes, different velocity, it means if you are not prepared to manage, or your environment or the databases you're using is not prepared to manage that data and scale to the required level, then a lot of time will be lost. And ultimately, by the time you get to the point that you're generating value, it may no longer be relevant. So there's been a shift in the way data is being managed. And this is why you have new concepts like the data lake as an architecture is different from a traditional data warehouse. The objective for the data lake is totally different. It's really to capture as much data as possible so that then you can do analysis on the data. Its focus is not so much on structuring the data, even though, as you can see in the chart, you can still ingest both structured and what you call unstructured data. And the structured data are things like your images, your videos, your free text, and so on and so forth that you generate on social media and other platforms. And then the velocity at which this data comes in, which what you see here in pink, the real-time processing engine and the batch processing engine, you can now begin to collect this data at a higher frequency. So the real time means as close as possible to when the data was generated. So as you're generating the data, you can transfer it and this can be captured. And the aim of the data lake is to enable these new ways of dealing with data so that you can capture different types of data, you can capture them at different speed, but also you can hold more data. So the volumes that you can hold will tremendously increase because of the way they've been designed to store data. They're cheaper. The type of technology that they use or infrastructure that they use to capture the data and store the data is a lot more cheaper than the traditional data warehouses. So this is what has given rise to the data lake concept. So as a data engineer, if you've been hearing about the data lake and data warehouse, these are the reasons behind the gradual shift from the traditional data warehouse to the data lake. It's still in a lot of places. They run side by side, but ultimately the data lake has come to enable the data warehouse to be able to deal with the changing data landscape. Okay. So differences between data lakes and data warehouses. So you have a list of parameters here that you can use to compare the data lake from data warehouse. When you talk about the data, like I mentioned earlier, data lake is meant to store everything. Data warehouse focuses on business processes. So it's selective because ultimately you are trying to answer business questions, and therefore you need to design the data to fit into the structure that will enable the business questions. And this is the whole concept of data warehousing, whereas data lake is able to capture as much data as possible because data is coming now from everywhere in different shapes and form. Processing the data is mainly unprocessed in the data lake architecture. So you store it like in the natural format of the data, and you see what that means later when you need to analyze the data. Whereas for the data warehouse, you want to already prepare it, make it ready and available for use. The type of data can be unstructured, semi-structured, or structured. Semi-structured means it's not fully unstructured. Unstructured is like when you have images or videos. This is not even in a text format, right? So you need to convert it first to some form of text format and then structure it into a typical column and row format. Semi-structured can already be in text format. So if you read about things like a JSON or HTML, so these are different structures for data, or data information is structured, but it's not fully in a table and in a row and column format. So it's semi-structured. You can still then finally convert that to a structured format. In data warehouse, it's mainly in tabular form, which is expected. What else here? If you go to storage, like I mentioned earlier, data lakes store at the lower cost. The data warehouse is more expensive. They meant to give fast response times depending on how you use it. If you're using it on ad hoc basis, that means you're basically querying the data warehouse and asking questions frequently. It gives you a faster response time. The data lake, actually, you're meant to do more heavy type of processing. So you run very complex algorithms once, and then it uses a lot of data and then generates an output. On those complex algorithms and using a lot of data, the data lake is actually faster than the data warehouse. But when you're using smaller data sets and you are querying them frequently, the data warehouse is usually faster. So schema, data lake is schema on read, which means your data is not structured. So when you want to use it, that is when you now learn about the structure of the data, and you then need to write your algorithm to be able to cope with that existing structure and translate it into the structure you want it to be. Whereas in the data warehouse, it's schema on write. So as the data is being stored into the data warehouse, the data is already structured, right? The structure that you want the data to be in, already, you basically write the data into that structure. Data processing helps for fast ingestion of new data, time consuming to introduce new content in data warehouse. And then tools. So you must have heard of Hadoop, and this is probably one of the big game changers when you talk about the whole data space, right? Was a technology that, as you know, was built by Yahoo engineer in the past. And basically, this has now become commercial. Well, it's still based on open source project, but a lot of vendors have now commercialized it as a tool. And most industries now have, at least in industry I work in, the telco operators, because in telecoms, you have a lot of data compared to a lot of industries. Most telco operators have one form of data lake or the other, but most of them usually go for Hadoop. And then, of course, data warehouse, like I said, are still the traditional vendors like Oracle, Microsoft, and SAP, and so on. Okay, so just to give you a bit of comparison between data lakes and data warehouses. Then also the what you call analytical sandboxes, right? So the data warehouse, data is structured for business processes to drive decision making, for reporting, and so on. The data lake is meant to capture as much data, to ingest the data. Data is typically in the natural form, not unstructured, not structured, and then it's meant to help drive different use cases that requires data, bigger data sets at different velocity, and so on and so forth. Here, analytical sandbox is quite important for data scientists because most of the input data sets for modeling is structured in a specific way, right? So you usually have what you call flat tables. And these are tables that allow you to be able to store a lot of data in columns. And so you have like a very wide table that allows them to create so many variables and engineer so many features that they can feed into their model. And based on that, make different predictions. The analytical sandboxes are databases or at least specific physical schemas or separation within a database that you can create these data sets in. And you can see in this image from raw data stores to batch processing to process data source. And ultimately, you can push that into an analytical sandbox that enables data scientists to do data discovery, do exploratory analysis, and ultimately build their models. Okay. So we've covered so far data warehouses, data lakes, and now we also talked briefly on analytics sandboxes. Hope you understand which is which and what they are used for and the differences. But like I mentioned before, the components we're going to cover here, I've only selected a few. This is not exhaustive. There are lots more components that we can cover. Just for the sake of time, and also just to do this as an introduction to give you a quick idea of these different concepts, I've selected these ones. So then let's quickly look at the domains and the disciplines. So for the domains and the disciplines, for the domains and disciplines, we're looking at data modeling, data pipeline development. I think this is one that most of you will be interested in, and data quality management. So I think these are some important domains that we can focus on today, just to give you an idea of what the data engineer should be concerned about in terms of how they help to make data available, ready for use. So data modeling. You have different types of models. So what's a data model? Basically is the structure that you, how you structure the data in simple terms, right? So a data model is basically a structure that you apply on data to make it ready for use. There are different ways you go about it, and there are different types of data models. But ultimately, what you're trying to do is to understand what business problem you're trying to solve, what questions you need to answer, what type of use cases you need to drive, and how do I structure the data in a way that I can link them together, I can have them separate, I can put all the different data points that I need, and how do I make sure that it's properly integrated and drives the different questions that I want to answer. There are different types of data models. It's a conceptual data model, which is a high-level representation of the data. As you can see, it's just looking at what you call data entities. So you're looking at time, product, sales, and store. These are just basically different categories of data that you can capture. So data about time, data about products, data about sales and stuff. Then you have what you call a logical model. This is a next level of detail, which now begins to put the field names, the column names. So for each of those entities, what type of attributes do you want to capture about them? What type of information do you want to capture about time? You want to know the date, you want to know the month, you want to know the year, the week, and products, you want to know the product description, you want to know the category, and so on and so forth. Same for all the different entities you have here. Here, you're looking at the attributes, and these attributes are more or less the columns that you end up with in a table. And finally, you have the physical model. Now, in the physical model, you're starting to add more information about the attributes to enable you create this in a database. Ultimately, data models are structured representations of data, which means they will end up in a database. And typically, this ends up in a data warehouse because you're already putting a structure on the data, or in some other form of application database, not just a data warehouse. But the whole idea is that you are structuring data so that you can store it in a database. For a physical data model, you're starting to add these attributes to ensure that you have information on how you can set up different things. So when you look at the dates entity, the time entity we mentioned at the beginning, now it's been changed. The table, the name now has been created as a table name. So you have what you call a dim underscore time, which is the dim is actually an abbreviation for what you call dimension. In data warehousing, you have what you call dimensional modeling, which we'll touch on in a bit. And the dim is used as a short form for dimensions. And you can then see here you have the different columns, the date ID, the date underscore desk, which is the description, and so on and so forth. And you have the data type. The data type is what format is that data going to be in when you store it in the database. So you have an integer, you have a varchar, you have, and so on and so forth. So when you do a data model, when you design a data model, so also the data engineer, one of the skill sets you could have is data modeling. Traditionally in data warehouse space, you had actually someone who was a data modeler, and their focus is actually in doing this data modeling. It's actually a key component of the data warehousing lifecycle because you need to structure the data. So ultimately, this person plays a key role in understanding what is the target structure that you need to put when you're bringing data from another source. How do you need to transform the data so that it fits into that target structure? This person defines that target structure. And that target structure is defined based on business requirements and the type of decisions, questions they want to answer to drive decisions or to drive different use cases. As a data engineer, this is a good skill set to still have because you still need to generally understand how you structure data to ensure that you can link your data sets properly. And when you build your pipelines, the target structures are designed in a way that you can ingest the data and capture them properly to drive the different reasons why you are building the pipeline. So I mentioned dimensional modeling earlier. So those are the different types of data models that you can build. These are the techniques for data modeling. So you could either use a relational modeling technique, which you typically find in application databases. So when you have an application, any type of application, a banking system, for example, would have a database behind it. The database usually is a relational database because the aim is to try to link all the different entities in a way that you are able to fully link them based on the relationships, right? So here you have a typical, customer products and other relational database. And this represents the actual business model. So customers usually will make orders. So you want to be able to link your customer to the orders, and you want to be able to link the orders to the details of the order. What exactly are they ordering? They order products. So you want to link the orders to the products, and then you can have different categories of products. And ultimately, you want to know who's supplying the products. So from customers to the orders they make to the products that they're ordering and to suppliers of the products, the relational database and the relational data model allows you to be able to link all that. And the objective here is to be able to store the data in a way that it protects the integrity of the data, which means you are able to do all this link after you store the data. That's the main objective of the relational data model. The dimensional data model main objective is actually for you to be able to read the data and use to drive decision making. And that's why it's structured slightly differently. What you have here is what you call the star schema. This star schema is, you can see the shape of a star because you have what the sales facts in the middle there, and you have the different dimensions, which is the date, the product, customer, supplier, and shipper, that coming off from the sales facts. You want to be able to read information about the sales and analyze it by the date of sale, by the supplier, by the customers. And what you do here is what you call a denormalization. And I don't want to get into too much some heavy concepts here, but the key thing, and when you read up a bit about this, relational data models, they are what you call normalized data models, and they're in the third normal form, right? Whereas the dimensional models are what you call denormalized data models. And in this way, you're trying to reduce the data as much as possible so you don't have data duplication. Whereas on the other side, you don't mind having data duplication. What is important is that the objective of structuring data in this way is basically determined by what you want to achieve. For a relational data model, you want to be able to drive application. This basically supports databases for applications. So you want to be able to capture the data in a way that allows you to link the data back when required. For dimensional data models, you want to store them in a way that allows you to read them to drive reporting and on business decisions. Okay. So key steps in the data modeling process. Like I mentioned, usually a data modeler will be involved in doing this. But as a data engineer, also this is good knowledge for you to know, of good knowledge for you to be able to do your work. The different steps here. So you need to identify the entities. Remember, we saw in the conceptual data model, we had those entities. You need to identify the key properties of each entity. So you need to add the attributes, as we saw in the next logical data model. You need to draw a rough draft of an entity relationship. You start to link the different entities, so products to orders to customers. You need to identify the various data attributes. And now you need to, for each entity, what are the attributes? So for customers, one information, you want to know the name, the age, the date of birth. For products, you want to know the product ID, you want to know the product name, so on and so forth. Then you map the attributes to the entities, which is what I mentioned now. And then you finalize and validate data model. So you need to go through the steps to be able to build your data model. There are different steps you can also go through depending on which techniques you're employing. But at a high level, these are the key steps that you need to go through to be able to model the data. So you need to identify the entities. You need to be able to identify what are the key properties for each entity. You need to do a rough draft of the relationship between the entities. Then you need to be able to identify what are the various attributes of the entity that need to be incorporated into the data model. And then you map these attributes to the entities and you finalize the data model. Okay. Then, so we've covered data modeling. Remember, if I flip back, so we've covered data modeling. Now let's look a bit let's talk about the data pipelines. So I mentioned at the beginning of this of the video that I'll be using a lot of video images to explain. So this hope is working. Yeah. I know sometimes maybe some people prefer to have text describing exactly what the image is about, but hopefully I'm explaining it well enough for you to understand. So for data pipelines, the objective of a data pipeline is really to move data, just like in the name of pipeline, right? So a pipe, you have an entry point, you have an exit. It's to move data from one point to another, just to simplify. Then there are different techniques and different ways of doing that. Traditionally, you've heard about what you call the ETL. The ETL stands for extract, transform, and load process. This is a process that is being employed in the data warehousing space to move data from the sources to the target, which is the data warehouse. And as you can see in this picture, you're extracting data from different source databases. This could be files as well. It could be databases. You are staging them meaning you extract them, then you store them temporarily in a location after you've extracted them. Then from that temporary location, you apply different rules to manipulate the data. to integrate the data, but ultimately to transform the data into the shape that you want the data to be in. Remember, again, we talked about the data model. In the data warehouse, there's usually a data model. That data model is already a structure in which you want the data to fit into. So the point of transformation is to make the data ready to fit into that structure that you define in the data warehouse, which is the data model. And once you've transformed it, then you can load it into the data warehouse. And then you can also transform it again to build those analytical data sets that can be used to build machine learning models. So the ETL process is a data pipeline process, more or less, right? So it's a way of moving data from the sources to the targets, and they go through that step of extraction, transformation, and loading. And in each of these steps, there are different things you need to be aware of as a data engineer. In the extraction step, you need to be aware of the source system, the system that is generating that data. You need to understand the structure of that data. You need to understand at what frequency can I extract the data? What protocol can I use to extract the data? And then basically in what form is the data captured in that system that I need to extract? Once you've extracted the data, in transformation, you need to think about what rules do I need to apply? Do I need to integrate the data? Do I need to aggregate the data? Do I need to calculate new values for the data? And there are different ways of doing this. And then ultimately loading into the data warehouse. At what frequency do I need to load? How do I need to load? Do I need to insert all the records? Do I need to update existing records? Do I need to delete before I insert? So there's so many things you need to think about. But there are tools today that have been built to enable you to do this. And these are graphic user interface tools, like GUI tools, that you can do drag and drop, that allows you to be able to build these pipelines and configure all these different parameters to be able to do the whole end-to-end process. Okay. So there are new patterns now for data pipelines because of the move to more big data type of architectures. You're dealing with more complex data. So the structure of the data has changed. The speed at which data is generated has changed. The volumes of data has changed. And so on. So, and the different ways data has been, different places data has been stored now. So you have data stored on the cloud, you have it stored in databases that are stored on the client premises, and so on and so forth. And data has been generated by different systems. So by devices, by machines, you have logs coming from also different systems. So the pipeline now that you're building using these different data sources and different data structures is a lot more sophisticated than what you would build in a traditional ETL process. And the way you capture the data, the frequency at which you capture the data has changed. So you need to stream the data in some cases because you want to capture the data in near real time. And the type of pipeline you build will be totally different. And there are different techniques to build such pipelines. You still need to capture the data in batch mode, which means that the databases that generated data in a more standard frequency, so it's lot less frequency. You also need to design the process to ingest the data. So as you can see here, you have things around replication and mass ingestion, streaming ingestion, which is when you stream the data almost in real time. You have API and application integration. This is when the data is stored in an application, and the way you extract the data is through an API interface, right? And ultimately, you bring all this data in. You can store them in a data store, initially in an operational data store to hold them. You can move them through different stages within the data store. You can then move them from one database to another database to structure the data in different ways into a data warehouse. You can split it into a data warehouse, which you see at the bottom part, or you can split some data as well into the data lake, depending on what needs to go where. And once you have them stored in these databases, you can then also share them with external data users. So you have the B2B data exchange, which is you basically supply data feeds to them. This can be through APIs, this can be through direct data feeds using file transfer protocols and so on and so forth. And then internal consumers as well can use it for machine learning, and for visualization. So this picture here is just to try to show you a bit how complex data pipelines can be now because of the different types of data you need to ingest, the different sources of the data, the structure of the data. versus in the previous one we saw in the ETL, where it's a lot more streamlined and the data is coming from typically a database or a file, and you're loading into a data warehouse at a more defined frequency, and there's a structure in place in the data warehouse that you need to fit into. Okay. As a data engineer, a lot of your work will be building data pipelines. So it's important to know all the techniques that can be applied in building these pipelines, and be familiar with the different tools that you can use to build the pipeline. So we've covered data pipeline a bit quickly, but I know there will be a Q&A session. So in case you have specific questions, please feel free to ask when we get there. Now I'll go to data quality dimensions. Because data quality management is one of the key disciplines as well. You've always heard garbage in, garbage out. So it's important that you address data quality issues when you have poor data quality. So when the data is not properly formed, or the values are incorrect, or if data is incomplete, you need to find a way to fix the data. Otherwise, it will impact the quality of the decisions and recommendations that you make. So in the data quality management discipline, they've come up with what you call data quality dimensions. So these are the different areas that you need to cover to ensure that the data is in good quality. So, or different topics or different dimensions, more or less, that you need to cover to ensure that data is in a good shape and form. So you talk about data completeness. So is the data complete? So the degree to which the necessary data is available, right? So you want to get all the data that you need to drive to make your decisions. You want to ensure that you've captured all that. Is data unique? You don't want to have duplication. This is quite common. You want to ensure that when you have customer information, you don't want to have two records for the same customer, because this can impact downstream when you're using it to build a pipeline. It could create wrong values, because when you join that table with another table, you can create duplicates. And when you, for example, calculate the number of sales that you've made to that particular customer, you may be double counting, and so on and so forth. So consistency, degree to which data is equal within and between data sets. So it needs to be consistent between one data set. So when you look at a particular column, a particular value of the same column in one table, it must be consistent to another table holding the same value within the same column, right? So if you're looking at location information in the customer table, you're looking at like an address in the customer table, but you also have an address table that actually stores in more detail. If you have, for example, a PO box in the customer table, which is the PO box for that particular customer, you want to ensure that the PO box is the same within the address table so that you can link them properly. They have to be consistent. Validity, the degree to which the data is within defined requirements. So here is just your testing to ensure that you don't have like the outliers that can really impact the quality of the data. So you want to test within ranges. Is the data within a range to ensure that the data is valid? And accuracy, the validity is more about the format and the type rather than the range. So sorry about that. The format in which the data is in, the type. So if you're expecting data to be a date, and you expect to be in a particular format, so you want to have the day before the month, before the year, you're checking if that format in which the data that you have collected, it fits into the expected format. Degree to which the data represents the reality, which is the accuracy. So is the number actually accurate? So if you're looking at sales number, the price of a product or the amount of sales you've made on that product, you want to ensure that it represents reality. And then timeliness, when the data arrives, is it still up to date? So you want to ensure that the data is available at the time when it is needed. Okay, so these are different concepts in data quality management that you need to be familiar with. When you test the quality of your data, you don't necessarily have to test across all these dimensions. Sometimes, especially when you do analysis, there's the 80-20 rule. You may not have time to really fix all the data quality issues, because maybe ultimately the decision you want to make, you don't need to have the final level of accuracy. Directionally, if you're correct, then you can still make that decision. In some cases, for specific use cases, data needs to be very, very accurate. It needs to be 100% accurate. There's zero tolerance for data quality issues. And this is where applying different rules to test the data to ensure that it meets the requirements across these dimensions becomes very important. Then data quality management, how do you do this, right? So there's this cycle, because it's an iterative cycle. It never ends. You keep going and refining the data more and more. There's no perfect data. You need to keep refining it. So if you start from defining, I think the middle part there, so identify and measure how poor data quality impedes business objectives. So you need to be able to profile the data, understand exactly how bad the data is. And there's a concept of data profiling, which you apply, and you have different tools to do this, but ultimately you're applying different statistical analysis. You're doing that on the data. So you're looking at the standard deviation of the data. You're summing the data, you're looking at averages, you're counting the data just to ensure that the data that you're using meets specific requirements. And then you can identify when there are outliers, when there's wrong data in there, once you do the profiling. Then you define the business-related data quality rules. So you define the rules that you want to test across those different dimensions that we looked at. So you want to check whether the data is complete. What does that mean? You define a rule. It means that when you look at the customer information, that all the customer information, you have, maybe 100 customers. You want to be able to ensure that the list of customer records that you have there, or customer IDs, match up to the expected number. Then you design the quality improvement processes. So once you've created these rules to test, if you find an error in the data, you need to design how do you fix that. So if there's a missing data, how do you impute that missing value? If the data is duplicated, how do you dedupe the data? How do you remove the duplicated data? Once you've designed those rules on how to fix the data, then you implement them, and you can then automate the process to clean the data and enhance the data. And then you monitor again to ensure that it's been fixed. And if not, you identify what has not been fixed. And this is how the loop keeps going until you find the data to the point where it is fit for purpose. Okay, so I think we've covered most of it now. And then I put this here to talk about some new trends in data engineering, because I've covered selected concepts. I've more or less cherry-picked some things just to talk about today. But what's important also is that this space is changing rapidly, just like anything to do with data analytics. And there are a lot of new trends, and maybe not even so new. Some of these trends have been around for years now. When you talk about the shift to cloud, the shift to the cloud is basically, a lot of people are now storing data on the cloud. Most of you must be familiar with the cloud. If you have an iPhone, I'm sure you know the cloud already. Basically, these are storage infrastructure that are managed by different companies. And if you have a business and you want to store your data in the cloud, you can rent space within the data centers and you can push the data there. It offloads all the responsibility of managing the data to someone else. The storage capacity is provided for you. Usually those environments are more elastic. They can expand the storage to cope with the different data needs, volume that you need to store, and so on and so forth. The servers that they store the data in, you don't have to manage them. They're all managed by the cloud provider. There's a big shift there because of the big data change as well, because now we're capturing data. A lot of data needs to be stored. To be able to do this, you need to store them cheaply. The cloud provides this opportunity to store them cheaply. And also you need to be able to store them and keep them for as long as you want. The cloud provides this opportunity. And also you need to be able to access them on demand. The cloud provides this opportunity. Now, another concept here, which is called containers. If you heard about microservices, this is actually a big shift. It goes beyond data, because this is a total shift in software development and the whole of technology architecture in general. But it's also very relevant in the data engineering space, because the idea now is to build, imagine you're building pipelines, right? You can build a big pipeline that moves data from one point to the other, and you can build a lot of rules. Remember what we said, you need to build rules to be able to collect the data, to transform the data, to calculate, to apply different rules and transform the data, aggregate the data, integrate the data. And you can do this using this approach of microservices, where the idea is to split this pipeline into smaller bits that you are able to then reuse whatever rule you have applied to build other pipelines. So you don't need to build big pipelines that only works once, but you can build different components. So like a jigsaw puzzle, you can build different components. So you can build a rule to basically calculate a particular value for the customer. You can build a rule to integrate one part of the data to another. But then that component you build using that tool, you can package as a microservice that you can supply or publish for another data engineer to use to build their own data pipeline. Some of these concepts, I think it's important to read up about them and go into more details than I'm explaining here. But the drivers for these new trends, like I mentioned at the beginning, is more the big data, the shift in the structure of the data we're dealing with, the shift in the type of use cases that we need to implement to leverage to use using this data, and the way the pipelines need to be to adapt to the changing data landscape and the changing demands for data use. There's AI-driven development. This is actually one interesting one on that development trends, because now you are ingesting a lot of data. You need to do all these different manipulation and transformation within the pipeline. Imagine doing this for when you have 1,000 or even tens of thousands of data sources that are ingesting data in real time, right? But then you also want to then apply rules to understand how to integrate the data or to integrate the data, or you want to apply rules to do all the different data quality checks that we talked about. To do this will be very, very difficult, right? Because imagine you then need to create new rules as you are finding out that the data is changing, because the structure of the data is not also constant. The structure of the data could be changing dynamically. To do all this manually or the way it's being done today is almost impossible. So this is where AI-driven development has come in, because it's adaptive and has a typical cognitive intelligence to be able to determine when things change and to adapt to create new rules or to select specific rules that you can apply depending on the data type or data format that is being ingested. And then in terms of use cases, a lot of privacy regulations use cases are coming up now, right? So you need to bear in mind as data engineer as well that the data that you are using needs to be protected. Not just needs to be in the right shape and form, needs to be cleansed, but also you need to be responsible for the data that you're using. Because so a lot of use cases now are meant to help to protect the privacy of the data that you're using, to ensure confidentiality of the data is protected, and so on and so forth. So I know I've covered a lot of things at high level. I'm trying to give a good overview of different concepts. I'll be interested to hear your questions. Hopefully I've given you a fair idea of what data engineering is about, or the key components within the data to decision life cycle, data to decision cycle, and what are different domains and disciplines that you need to be aware of. So it's been truly an honor participating in this. I would love to do more of this. It also helped me to remind myself of some of these trends and some of the different topics that I've been used to or I've not used in a while. But like I mentioned, it's been an honor, and I hope this has been useful for you. Hopefully we'll catch up in the Q&A session, and I'll be able to take on whatever questions you may have. So thank you very much. Stay safe, and hopefully we'll be in touch soon.
Please visit this website, that is www.datasciencenigeria.org/new trainings, to discover more about our training programs. Now, if you have been considering learning data and analytics or starting a data science career, here is an opportunity for you. Don't miss our special May Professional online classes. The classes start tomorrow, May 16. And guess what? You can still register to attend today. Please call Sheung on +234 814 00 888 00. I'll go over that again. +234 814 00 888 00. You can join the business and data analytics stream, which goes for just 30,000 naira, that is less than $100. And you can as well also join the data visualization classes, which goes for just 20,000 naira.